Today we're going to do case number 3. So what I want you to do now is using your own mass, so you don't have to ask anyone else for their mass, is that calculate the magnitude of the gravitational force between you and between Earth, but in a special case, when you're standing on the surface of the Earth. So what you need to do is here you are. You are standing on the surface of the Earth. Everyone, you're standing on the surface of the Earth. So first of all, what's mass 1? Your mass. So everyone here has to have a different answer. Mass 2, come on, what's mass 2? The Earth itself, which we already covered from yesterday. What's the distance? Now you need the distance between what? You need the distance between your center and the what? And the Earth center. So if you think about it this way, look, everyone, oops. If you think about it this way, now what's the radius of the Earth? It says so on the diagram. 64,000 kilometers. So that means, everyone look, this is the Earth. From here to here is how much? 6,400 kilometers. Okay. Now let's be honest here. Yeah, it's on. What's okay? But you still have to go to your what? Your own what? From center to center. Okay. Let's be honest here. Okay. How tall could I be? I'm 5'9". Okay. So that's definitely less than what? Less than 2 meters, right? Okay. Even if I was 2 meters tall, even if I was 2 meters, like 6'8" or 6'9", how much would half my height be? Assuming that my center of mass is where, by the way, is your center of mass exactly halfway through your height? No. Your upper body usually what? Weighs more than your what? Than your lower, which means your center of mass is shifted more below or more up? More up because there's more mass concentrated here. So that means what? But let's say your center of mass is exactly your height divided by what? Divided by 2. Even if I was 2 meters tall, my center of mass would be exactly how far from the ground? 1 meter. Making sense? Okay. So you need to go from here to here, and then what? How much extra? How much extra we said? 1 meter tops. What's the radius of the Earth? 6,400 kilometers. How much is that in meters? 6,400,000 meters. If you have if you have $6,400,000, then one guy gives you $1 more. Does that really make a difference? So because it doesn't make a what? Doesn't make. So what does that mean? If we do not account for our 1 meter extra, does that really destroy the result? That's my point. Thank you. So even though we're doing center to center, can we just skip the center to center and just do the radius of the Earth? Do you see what I mean? Again, this is called what? Approximating for what? For a meaningful result. So go ahead. Use the distance as just what? 6,400. It's in kilometers. You have to switch it to what? Go. Use the same equation as yesterday. FG, F capital G. So you have to do F capital G equals G, your mass, times the Earth mass, divided by the radius of the Earth squared. Go ahead. Let's see what answers you all get. We're still using the big equation. The big equation? No. The big equation is capital G. Everyone, is this equation correct? Yes, because is this gravity or still gravitation? Yes, gravitation, you never use small g. It's always capital G. The quiz? Uh-huh. Yeah. I don't know. It depends what the question is asking for. Exactly. What word is in the question? Gravity or gravitation? That's got to change everything. I don't know. I don't even remember the question. But, okay, but go ahead. Come on. Work on this now. Go. Come on. You don't need anyone else's numbers. You need your own mass in kilograms. Your own mass in kilograms. Whatever you want. I can make an Excel sheet and show you by changing the mass how the number changes. But go ahead. Come on. Actually, you know what? Okay, I believe the lightest person here might be like, let's say 45 kilos. 99 pounds exactly. 45 kilos is exactly 99 pounds. Mm-hmm. All right. I got an Excel sheet with all the possible values you can get. So let me show you basically using my own math what I need you to do. I need you to do this. I need you to do this. FG, everyone look. FG equals 6.67 times 10 to the negative 11. Okay. What's my mass? I use 62 times. What's the mass of the Earth? 5.98 divided by what? 6.4. What? But with what? With a square. Don't forget the square. By the way, could you do this through using the split way I did yesterday? 100. I would encourage you to do that. Yes. That was it. Yeah. You can. Yeah. So let's split 6.6. Again, this is my number, but I want you to follow the same way. Times what? 62 times what? 5.98 divided by what? Come on. 6.4 squared times what powers of 10 survive? Times. Can someone tell me now what's the power here? 10 to the what? What's 10 to the 6 to the power of 2? Yes, you don't add, you multiply. Okay? So can I do this in my head? This part? I sure can. What's 24 minus 11? 13. 13, take away 12. No, 1, just 1. And then I need to do this one. All right? Let's do it step by step. Okay. 6.67 times 62 times 5.98 equals divided by 6.4 squared. 60 point, I'm going to say 60.4. So what would this be? Uh-huh. Okay, hold on. What math did you do? Did you use? 100. You used 100. So all of your numbers are the same, except for which one? Not everyone. We should all have the exact same numbers, except for this. Everyone should have a slightly different number depending on your math. Okay, everyone, pencils down. Look at the screen. So I made an Excel sheet or a Google sheet. Everyone, look at this. All right, there we go. I start with what mass? What mass? Where's the zoom? Sorry. Zoom. I start with what mass? I assume that no one in this class is lower than what? 45 kilograms. And then I calculated the what? I calculated the force. Let me show you the equation. Everyone, check out the equation. Ready? Yes, you should be. Boom. That's the equation on top. 6.7 times 10 to the negative 11 times what? What's D4? What's cell D4? D4. That's the what? That's for someone's mass who's what? So G times M1 times what? 5.98. E24. What is that? Yeah, what's that? The mass of the what? The mass of the Earth. And then divided by what? 6.4 times 10 to the 6, but what? Squared. If you have a mass of 45 kilos, the force between you and the Earth right now should be how many newtons? Okay. Okay. Shout out. Who's in the 40s? Whose mass is in the 40s? Okay. So what was your answer? Sorry, what was your mass? The mass that you used? 44. Use 44. So what answer did you get? Oh, 45. Sorry. So 45. What was your answer? Which is very close to what? 438. Okay. Who's in the 50s? Who's in the 50s? Who has got a mass of 50 something kilograms? No one? Who's in the 60s? What mass did you use? 60? Okay, 60. Hannah, what answer did you get? Boom. Done. That's it. What did I do, by the way? I'll show you how I did it. Look, this is the way you use Microsoft Excel. You actually what? Look, I know if you used it before. I just do one cell. I just do one cell. Look, and then I go here. You see this plus sign? Double click. Boom, it populates. Yeah, that's a life skill. That's better than TikTok, Instagram, and Snapchat combined, because that actually shows you something that will really benefit you. So Ali, you used 100, right? What answer did you get for 100? Boom. So what did I do? Look, I did 45 here, and then what did I say? I said, go to this cell, D4, and add what? Add what? 2.5. And then I just populated the whole thing. Do you see what I mean? So it's jumping in one. So Hannah is saying we do 105. Well, the good news about 105 is that it does fall under what? 2 steps after this. So look, I'm gonna even go more, and then I'm gonna click. If you have 105, you're 102 2 point whatever. I don't have 61. I have between 60 and 62.5. So you should be, Jadam, you should be between these two numbers. You should be between 584 and 608. And since you're 61, you're almost right in between, right? So you're like the average. What's the average? What's in between 584 and 08? 16 and 824. You should be about 600 and, sorry, no, 12. 600, 596-ish. What'd you get? You mean 500? 504. Yes, perfect. Yes, you're good. Yes. 71. Yep, you're right in between what? 681 and 706. Does that make sense? There you go. So whenever you want, you can always use Excel to check your answers. Okay, so let's go back to the notes. Okay, so everyone, pencils down. Question for you now. When we did case number 1, did we all get the same answer? Why? Case number one. Because we paired it, 2 people different, right? So each pair should have gotten what? Something different. How about case number 2 yesterday? Did we all get the same answer? Yeah, because we were talking about things out in space and they had their own masses. How about now? Yep. But did we all use all different numbers in the equation, or did we all use just one different number each? What was the only number different in the big equation? Our own mass. So what does that mean? Was G the same for all of us? Was the mass of the Earth the same for us? Was the radius we used the same for us? So how many symbols are in the equation? 5. The G, the M1, the M2. Sorry, 4 or 5. Sorry, 4. G, M1, M2, and what? D squared. G is the same. M2 for the Earth is the same. And what? This is the same. Can we pull these 3 out, not out completely, just move them to the side and calculate them all at once? Do you see what I mean? If we all will use the same product here, why didn't we just calculate it? So look at this. So we have the following formula to calculate the force of gravity of any object as long as it's on what? On the surface of what planet? The Earth. Does that make sense? See, G is universal, so it doesn't have a subscript. Mass is only for the what? Mass of what? Earth. Mass of what? Object, which is U. And then radius of what? R means what? Radius of what? Earth squared. Okay. Which 3 can we take out? Not take out, just isolate. Which 3 are going to be the same for all of us? The G, the Earth, and the Earth. So we agree that this is correct. Come on, copy. I'm going to show you something very interesting. I'm building up to it. You're getting there. I'm building up to what you already have a hunch about. Okay, so we can isolate G, capital G, of course, M Earth, and R Earth, since they will be the same for all of us as long as we are on the surface of the Earth. Okay. Now, can I calculate for once and for all the value of this big bracket? Can I calculate right now the value of the bracket? Yeah, I have the G, I have the mass of the Earth, and I have the what? I have the radius of the Earth. So everyone, you have a blank slide next. Let's write the following equation. Okay. Okay. Boom. Come on. So the value of the go ahead. So the value of the expression in the bracket is this guy. No, this is the blank slide. This is the blank slide after force of gravity. Start by writing. You don't have to write the value of the expression. You can just immediately write the equation. How can I do that calculation? Can I do the split method? Can I just, keep my head straight through the calculator and do it? Yes, I can. Well, either way, actually, you know what? Do it for me. Go ahead. let's see after a few days of experiencing with your calculators if you can do this on your machines. Go, come on. Go ahead. Cell phones or calculators, I don't care. Oh, oh. No. Just I want you to do this first, everyone. Do this level first, clean up, and then divide by this after you put it in a bracket and square it. I'll actually show you what we get. We'll building up to it. That's why I told you believe it. Don't know why it is yet. Now I'm gonna prove it to you. Okay, so what's 24 minus 11? Come on, 24 minus 11. Come on, 24 minus 11. 13. How come this is 14? You know why? Because what's 6.67 times 5.98? That's bigger than 10, right? So when it makes its scientific notation, it steals the power and it makes it what? Less than 10. In other words, I'm confusing you. I know. In other words, this is, where's my thing? In other words, without scientific notation, this would look like this. Everyone, this, 1 second. This would look like 39 point what? 887 times 10 to the what? Times 10 to the, do you see what I mean? Those two are the same. Those two numbers are the same. But here, 13 became what? 13 became what? So that means the power of 10 went up, which means this number has to what? Go down by just flipping it. Yes, I know. That's how exponents work. It's a steal. It's a balancing act. You steal, you have to compensate. By the way, same thing for this one. If you did this in your head, you would say, hey, what's 10 to the 6 squared? What should this be? Come on. 10 to the 12. How come it's 13? Same principle. It used to be 4096. The number that gave me an Ali trouble. 6.4 squared is 40.96. Yes. Now divide that. Go ahead, everyone. Divide those two numbers. Go ahead. Divide those two numbers. And please use the EXP notation. Because I guarantee you, if you do this without using brackets, you're going to get the wrong answer. Sure. Yes. Use the EXP. It's already whatever it is. What number did you get? How many people are getting 9.737? This is very close to what? There you go. That is 9.37. 7.73, sorry. Is that a coincidence that our answer is suspiciously close to 9.8, which is a very special number for our planet Earth? Gravitation. Here's my question to you, though. How come the numbers are different? How come we didn't get exactly 9.8? This needs to be discussed, and it's only going to take us 1 minute. How come we did not get 9.8? Who would like to guess? Rounded. There's another word other than rounded that you can do. I have a question for you, everyone. How did we get the 9.73? Did we perform an experiment or did we just do a theoretical calculation? Come on. We did a theoretical. We did not do an experiment. We did just what? A theoretical. Also, we assume that the Earth is a perfect what? Is a circle. Is the Earth a perfect sphere? No. It's actually not. It's actually what? It's actually it's more bulging at the equator, like at the center, and flatter at the what? At the north and south pole. Okay, you know what? Even if it was what? Listen up, everyone. Even if it was a perfect sphere, does the Earth have perfect density? Your body doesn't even have perfect density. If I take everyone, if I take a pound of flesh, let's say I take a small cube of flesh here, would it have the exact same structure and composition as a cube of flesh here? What happens to the Earth as you go in? Yes, exactly. And you have the layers and the crust, the core. Do you see what I mean? So is this theoretical value decent? Is it decent? Because it's very close to what? 9.8. But is it the correct one? How come 9.8 is the correct one? Do you think the 9.8 is a theory or an actual experiment? Which one do you always believe, the theory or the experiment? Experiment. I don't care how amazing the theory is. You never get, I told you, they never give you a Nobel Prize until someone does a what? Does an experiment to verify that the theory what predicts whatever is saying it's predicting. Do you see what I mean? So, but at least Do you see now how theory could still what? Be what? Be what? Close enough? There you go. So basically, can the Earth somewhat be approximated as a perfect sphere? Somewhat, somewhat. Yeah, that's my point. Our theoretical explanation went kind of, in agreement with the experiment. So what's my point here, everyone? This big bracket used to be what? 3 things multiplied together, right? Sorry, 2 things multiplied together divided by something else. So what does this mean, everyone? By the way, I combined 2 slides, I think, for you in one. Yes. Oh, forget this one. Sorry. I think. No, this is there. Yes. So, do you need to use this now when you are on Earth? On. No. Why? Because we isolated 3 of them, and we can just do that. Didn't I already give you that equation? I did. But I told you don't ask me why. It is what it is. I told you I'm going to prove it to you. Can you rearrange this equation to solve for mass? How? If I give you the force and I asked you how much is the mass, what do you do? Yes. So everyone, go ahead. And you know what? Good idea, Ali. Let's actually what? Let's write the rearranged equation. Where is my thing? They want to see my. Okay, just write m object equals. Thank you. M object equals fg over 9.8. This is equivalent to m object obj equals f. Did anyone notice that one symbol changed here? Yeah, what is it? I am not using what? I am not using capital G anymore. I'm using what? Why am I using small g now? Because where is the object located? On the surface of the Earth. So is it gravitation now or is it gravity? There you go. So what does that mean? Gravitation is always the general case, but when you're on the surface of the Earth, what can you call it? And do you have to do the big monstrous equation? You can just do that equation that a grade 2 student can do. So when you are on Earth, can you use that one? When you are in the International Space Station, can you use that one? Perfect. So last thing for today. Oh, one more. What's the conventional symbol for the gravitational acceleration? G. And what's the value of G? The famous what? 9.8. Yes. Therefore, what's the force of gravity on any object on Earth? Fg equals mg. That's the equation. And why is it so easy to remember this equation? Everyone say it. Fg equals mg. It rhymes. Fg equals mg. Is that milligrams? That's not milligrams. That's what? That's mass times. Many people think, oh, that's milligrams. It is. But if you really understand physics, it's mass times gravity. Everyone, you have homework. You have homework. Tell me how strong the gravitation of the moon is. All you have to do to calculate any gravity acceleration of any planet, as long as it's spherical, and as long as it's not hollow on the inside, like it's got mass, like not a balloon, is that, what do you need? No, what do you need? You need the 6.67 times 10 negative 11. What do you need about the moon? What's the mass of the moon? Come on. Who remembers? 7 point? 7.35 times 10 to the 22. What was the radius of the moon? How many kilometers? Kilometers. I'm not going to give you in meters. You have to do something on your own. So 1,735 in. That's your homework. Till cap 6.67. 6.67 times 10 to the. Okay, everyone, let's go to the next slide. Okay. Who knows what weight is? How many people, how many times have you heard the word weight in your life so far? Every single day, right? Here's what people actually, everyone listen up. Today, the word weight should start meaning something different to you then every single time it meant something to you when before. What is the definition of weight? Weight, okay, Arabi, if I ask you right now, what's your weight or how much do you weigh? What do you tell me? Say again? Give me a unit. No, give me a unit. 85 what? You're not 85 pounds. Okay, 80, let's say 85 pounds. You can convert that to what? By dividing it by 2.2? 2? No, he's already in pounds. Kilograms. Guess what? You've been using the word weight wrong all of these years. Yes. Yeah. Weight in physics doesn't mean how heavy you are. In physics, weight is how much force of gravity you're being pulled down by, which means it's measured in what? Newtons. Do you see what I mean? Every time someone said, how much do you weigh? What do you just say? Oh, 62 kilos. That's not your weight. That's your what? From today, weight and mass should mean totally different things to you. Outside on the street, they mean the what? They shouldn't. Okay? In physics, they are completely. By the way, are they related? Think about it. If you have a higher mass, does the Earth pull you down with a bigger force? We just proved it. We just did the Excel sheet, right? But is mass and force the same thing? No. Think of units. How do you measure your mass? In what? Kilograms. How do you measure your weight or force? In what? Sorry, Newton and kilogram do not measure the same thing. But are they related, though? Through what equation? Fg equals mg. Do you see now? All right, so everyone, weight is what? What, sorry? Dyne. Dyne. D-Y-N-E. Dyne. Okay. So another name for the force of gravity on an object, obviously should have said what? Force of gravity on object where? On the surface of the planet. But the fact that I'm using gravity means I am located where? On the surface. Thank you. When you hear gravity, you know that you are very close or on the surface. It's simply its weight. So in other words, what's weight? It's the amount. Why am I saying the amount of force? Why did I not say the force? Everyone, what's the difference between saying the amount of force and the force? Force is by definition a what? Force is by definition a what? A vector. Where does the force of gravity always point? Down towards the what? The core or the center of the earth. I just said what? The what? The amount. Am I ever going to ask you for the direction of the force of gravity on you? We always know it's going to be what? Straight down. So I just care about the what? The magnitude. You see what I mean? Weight technically is a force, but I always treat it just as a number. But technically it is a force. So it's the amount of force by which an object is being pulled down towards the center of the earth or straight down. What should be the symbol for weight? Don't look at the screen. What should be the symbol for weight? Here's the problem. W, no, here's the thing. Both of them are already used. Lowercase w is used in math for what? In geometry. In geometry, math. What do you use W and L for? Think geometry. Length and width, so it's already used. How about capital W? What did you say? Okay, you're giving it to me as a unit. Watts of like light bulb. I'm talking about as a physical symbol and equation. Ladies and gentlemen, we are going to use W in about 4 or 5 weeks. Sorry, 3 or 4 weeks. When we talk about energy and work. No, that's electricity and magnetism. Yes, we are. All of that stuff. But my point is, W has already been what? Why invent a new symbol when we already have a what? Do you see what I mean? Weight is equal to what? Do we have a symbol for this guy? So why invent a new symbol? There you go. Weight and Fg are the same. Done. Aha. So everyone, listen up. You want to mess with people? Actually, you mess with Good Life when you go sign up for a membership. When they ask you, what ideal weight do you want to get to? Write it in what? Write it. No, don't write Newton, because you might get someone who actually understands physics. Just write it in the hundreds. Just write 974. I'm like, what the hell are you talking about? Well, what? That's my weight. Are you wrong? No, you are physically correct. Do you see what I mean? Because now the word weight means what? Pull down force. What does mass mean, though? If your younger sibling who really, everyone listen up. If you have a younger sibling, grade 4, he's asking you, what's this mass? What is mass? What could you define it to them as? Don't use any fancy words. Because unless you can explain it to a kid, you don't understand. How heavy you are. Okay, how about another way? What's the definition of mass? It's the what? Yes, it's the amount of substance inside of what? If I take you to the moon right now, do you lose any electrons, protons, or neutrons? You still have the same mass, but what changed? The environment changed. Yes, good. So, what's the definition of mass? The amount of matter, the amount of substance, heck, the amount of stuff that you are made of. All the protons, neutrons, and electrons making you up is your total mass. By the way, does mass ever change? No. Thank you. Unless the question says what? Mass has been gained or has been what? Lost. You always assume that mass of an object stays what? Constant and fixed throughout any problem. By the way, in grade 12, we will deal with varying masses. We will deal with collisions and explosions. When we talk about, how many people have heard the word momentum? Momentum is not part of grade 11, but it's a huge part of grade 12 in first year. Momentum happens when two things what? Collide, or two things. So either with what? With synthesis or disintegration. We'll do that then. Okay? All right, everyone, let's compare. Give me one difference between those two. This one is measured in what? What's the other one measured in? Go. Can someone give me another difference? Oh, it's actually nice. So in other words, okay, does mass ever change? Does weight change? Even if I take you to top of Mount Everest, does your weight slightly change? Yeah, because you're further away from the what? From the center of the earth. Yes. Same thing. Same everywhere. Depends on location. Not a force. What about weight? Come on. Not a force. What about weight? Is a force. Yes. Which means this is a scalar and this is a vector. What did I say? Vector what? Technically, I will never tell you what is the direction. However, when you sketch a diagram, which way should FG always point? So you see, that's why I'm never going to ask you for direction, because you're always going to give me a diagram with the direction on it. Is that all the spaces we have? All right.